Good morning and welcome to the Q&A session 20 from the chapter of wave optics. The topic is the calculation of fringe width in a liquid. And based on this topic, I have one question for this session which was asked in the IIT JEE main examination in the year 2025. So ये question इसी साल का question है and the question here is in a Young's double slit experiment, an apparatus is immersed in a liquid of refractive index 1.44. The slit separation is 1.5 mm and it is illuminated by a parallel beam of light whose wavelength in air is 690 nanometer. So the fringe width on a screen placed at a distance of 0.72 meters from the slits is. So these are the four options which we have been given and we have to find the correct option. So in the session number 13, we have learned that if a setup is immersed in a liquid of some refractive index, say n, that is in a Young's double slit experiment, if some apparatus or any setup is immersed in a liquid of refractive index, say n, then the fringe width is equal to lambda d upon mu small d. Here mu is what? This is the refractive index of the liquid in which that entire apparatus or the setup is immersed. D is the separation between the slits, that is the slit separation, and capital D is the distance between the screen and the slits. This capital D is the distance between the slits and the screen. Lambda is the wavelength of the light in air. So here I will be simply using this formula and I will putting the values which has been given in this question in order to find the fringe width. So ये एक बहुत ही आसान क्वेश्चन है जो कि IIT JEE Mains 2025 में पूछा गया है. So the fringe width when an apparatus is immersed in a liquid of refractive index 1.44 will be equal to, now here lambda is in nanometers, so that is this is the wavelength which is equal to 692 nanometer. So I will convert this into meters. So 690 into 10 to the power minus 9 into D. D is what? This is the distance between the slits and the screen, so which is equal to 0.72 divided by mu. Mu is the refractive index of the liquid which is equal to 1.44 into D. D is the separation between the slits. This is equal to 1.5. It is in millimeters, so I will convert this into meter. So this is the fringe width when this apparatus is immersed in a liquid of refractive index 1.44. So now simply we have to solve this value. So beta will be equal to 690 into 0.72 and this will be equal to this 10 to the power minus 3 will go into the this numerator. This will be equal to 10 to the power minus 6 and divided by 1.44 into 1.5 and this is the value in meters. So if I solve this this equation, I will be getting the answer in meters. That is the fringe width which I will be getting from here. With this will be in meters. So beta, that is the fringe width. This is equal to 690 into 0.72. This is equal to 496.8. 496.8 and if I multiply this is equal to 1.44 into 1.5. This is equal to 2.16 and into 10 to the power minus 6 meters. Now I have to find the answer in millimeters. So what I will do is I will write this equation as 496.8 into 10 to the power minus 3 into 10 to the power minus 3. This is in meters. Now this 10 to the power minus 3 can be taken in the denominator. So I will be getting this value, and this is equal to 496.8 divided by 2160 into 10 to the power minus 3 meters. So this is in millimeters. So this is the value in millimeters. This is equal to 496.8 divided by 2160. So this is equal to 0.23 mm. So the fringe width on a screen placed at a distance of 0.72 meters from the slits is 0.23 millimeter. So the correct option here is D. So thank you very much for joining this session. In the next session, I will continue to I will come up with another question which has been asked in the JEE main examination from the same topic of fringe width. So till then, have a nice day. Bye.